Okay, this is the third network, the base explanation for the IEEE 14 plus case, base case. As you see here, it is the same thing. It is we have the main program and load flow program and the data of IEEE. The difference between the other networks, previous network, it is that this is the transmission and looping network, but in IEEE 10 and 33 it is the distribution network, radial network. So the load flow is using here the Newton-Raphson network to get the voltage and current in each branch and buses. If you open the data of the network, as you see here, we have the bus data and the line data. As you see here, the bus data, it is the number of bus, the voltage at each bus. This is the initial voltage, the theta, it is the angle of the voltage of each buses, the generation power, reactive power generation, power load of each buses, and the reactive power load and the maximum reactive power and minimum reactive power, and the type of the buses. What do you mean the type of the bus? It is the three type of the bus. The slack bus, as you see here, it is one, and the PV bus, it is the 2, and the PQ bus, it is 3. So this is the number of or the type of buses. As you see here, each buses we have some specification, and if you go to the line data for IEEE 14 bus system, as you see here, this is the number of line, as you see here, and then also it is this is the sending in bus, and this is the receiving, and this is, we have 3 parameters or 4 parameters, sorry, the resistance, reactance, and the inductance, reactance, and it is the capacitance and the tap changer here. As you see here, this is the line data, and after that we preparation the data and the Y, as you see here, the Y bus admittance, and this is to using in the load flow. The output from that, it is the Y admittance of the system. And if you go to the base case, the same thing of the base case, it is two things. The first thing, it is the load flow program, and then to print the result, the same result for all the program: power loss, reactive power loss, voltage power loss, reliability, energy not supplied, and minimum voltage. And the last thing, it is to plot the voltage profile of each buses. If you go to the load flow program, the same thing. It is the output power loss, reactive power, voltage division, and the voltage profile, reliability index, and energy not supplied. And after that, we call the network data, as you see here, in the Y admittance, and then we prepare that data. Prepare the base MVA, number of bus, type of buses, slack or PV or PQ, specified voltage, voltage angle, generation power, reactive generation, P load, power load, and load reactive, the minimum reactive power limit, the maximum reactive power limit, and then we calculated the difference power. That means the flow power. The difference between it is difference between the generation and load power, and not the same thing. Generation reactive power and minus the load reactive power, and specified the power flow power in each buses. And then we calculated also the conductance matrix and substances matrix, and also we defined which one it is the PV or slack bus, or which one PQ and P buses. And then also we defined the number of PV buses and PQ buses. As you see here now, it is started to the loop that makes the load flow. The first thing, it is to calculate the power flow of each for each buses, and then we check if this buses, it is the PV buses. We manipulate, we correct the voltage until to reach the minimum or maximum limit of reactive power by correcting the voltage in each buses. And after that, now we go to the calculated Jacobian matrix, as you see here: Jacobian 1, Jacobian 2, Jacobian 3, Jacobian 4, and after that we get the Jacobian matrix, and then we also calculated the correction vectors, as you see here. And after that, from the correction vector we extract the voltage angle and the voltage magnitude. And after we extracted the voltage magnitude and angles, then we go to the make some updated state vectors for the voltage angle and voltage magnitude, and we calculated the tolerance. If the tolerance it is less than the 0.00001, the iteration will repeat it. But if you exceeded it is less than 0.00001, the iteration it is closed and go out from this iteration to calculation the losses. Now we have voltages. We can calculate the power flow in each line, and also we can calculate also the losses, the power losses, as you see here, and the reactive power loss and the voltage profile index. And after that also we calculated the reliability index and energy net supply that dependent on your reference paper. And after that we go back to the base case code or file to print the result from here. As you see here, we get the run, and as the same thing, it is the voltage profile for the IEEE. But as you see here, it is higher, it is high voltage profile, it is higher than 1. So the better voltage profile to near or near the 1 per unit. If you go above or go down 1 per unit, the voltage profile called it is not the base voltage that we want to the system operating on it. So the voltage profile near to the 1 per unit, that means better than above the 1 per unit or below the 1 per units. The last thing, it is the printed the result as you see here that mentioned before. Thank you for your listening. We hope it is understand this code, and in the next step we will go to the PSO cases to explain that case. If you have any question or any questionnaires or anything, you can tell us to help you where's the problem. Thank you very much.